so what we're going to do today is we're going to take a look at section, I think, P-4. Yes, section P-4, which is going to be polynomials. All right, and again, polynomials, you've done tons in Algebra 2 with polynomials, so this should be a good review. You would have done, again, an entire chapter in Algebra 2 dealing with polynomials, and all we're going to do is hit the highlights today and just review the major concepts of dealing with your polynomials. And across the board, polynomials are not difficult. All right, you make a lot of silly mistakes. You drop negatives, you multiply something wrong, you add wrong. Okay. All right, so everybody's, if you're in the room, everybody's laptop shut because we're taking notes. Thank you very much. Okay. All right, so let's start with first thing that you should do with polynomials is they're going to expect you to be able to simplify. Okay. Now, this is really no different than adding and subtracting like terms, except they actually give them to you in polynomials. So they put a set of parentheses around, and then they'll go negative 7x to the third plus 2x squared minus 4x plus 6. All right, and that set of parentheses around there indicates that that is a polynomial. All right, and then maybe they will either add or subtract, and they'll give you another polynomial, 4x to the third minus 5x, maybe plus 8. All right, so this is literally no different than adding and subtracting like terms. The reason they call this adding polynomials is because when you put that set of parentheses right in there, that indicates here's a polynomial. Polynomial meaning something with many terms in it. Okay, same thing over here. They put that around there. If it's add, you literally go through and match up the terms. Okay, so there's a negative 7x to the third. There's a 4x to the third. So I can go ahead and add them. I'm going to get a negative 3x to the third. Okay, now on the 2x squared, all right, there is not an x squared term over there, so you don't have to do anything with it. You're just going to keep it in your answer. So plus 2x squared. All right, if I put together the negative 4x, don't forget the negative in front, and the negative 5 over here, that's going to be negative 9x minus 9x. All right, and then I can add the last two, the 6 there and the 8, and then I can add that and get a 14. Okay. And so you can see, obviously, there's lots of places to make mistakes. If you drop a negative, this isn't hard. Now, the way I have written this, it is in standard form because the exponents are in decreasing order. It goes from an x to the third, x squared, x to the first. This one has an imaginary x to the 0 power. So the variables are in decreasing order of those exponents, which makes this polynomial in standard form. Okay, now when it's in standard form, I can look at the leading term. All right, right there would be the leading term because it's in standard form. So if I asked you just what is the leading term, you would tell me negative 3x to the third. All right, from that leading term, that tells me what the degree of the polynomial is. The degree of this polynomial is going to be 3. Ooh, because it's the exponent. Don't think it's the coefficient. It's the exponent. So the degree is 3. The leading term gives you the degree. A little bit later, that degree is going to tell us about end behavior. It's going to tell us what the ends of the graphs are doing when we graph that polynomial curve. Okay. Now, this type of adding polynomials where I've just got a single variable, that was really a lot of Algebra 1 and actually a large portion of Algebra 2. However, we can make these terms way more complicated because we can have an x to the third, an x squared, x to the third y. We can put 3 terms in there, 3 little letters. Okay, so let's just take a look at the degree of polynomials, but then in different forms. Maybe ones that are more complicated. All right, let's suppose I had a polynomial in more than one variable. So I had something that looked like negative 4x to the third y squared. Here, let's actually do a little bit more than in my online notes. Let's do plus 7xy to the fourth, and still 5, minus 8x to the 4th, y to the 5th. Let's do that. Okay, it's still a polynomial because I've got more than, 2 terms. Well, trinomial specifically, but 3 terms. Let's put another one on there so we can actually say polynomial. 4xy. There we go. All right, now, this is not necessarily in standard form. Okay, we're not going to get overly worried about standard form because I just randomly made up 4 terms here. All right, but what we're going to do is we're going to take a look at each individual term and determine the degree. Okay, so I'm going to look at this term and I'm going to add those exponents up. When I add those exponents up, I get a degree of 5 right there because 3 plus 2 is 5. When I do this term, again, there's an imaginary 1, so my degree of this individual term is 5. If I look here, I add up those exponents, I get a degree of 9. All right, and on this one, putting in those imaginary ones, I get a degree of 2. All right, now what you do is you look at this, and then you find out which term has the highest degree.
I'm freshman, S through Z. All freshmen, S through Z in the main gym.
All right, this term has the highest degree. So since that term has the highest degree, that one is the leading term. That one is classified as the leading term. So I could ask you what the coefficient of the leading term is. It's -8. The degree is 9 because I added them up. All right, so a little bit different way to think when you've got more than just one variable in there. Okay. So the overall degree of this polynomial is 9. Let's write that down. Degree equals 9. All right, now let's take another polynomial in another form. Let's do a factored form. Okay, when a polynomial is in factored form, all right, you're going to have maybe something like a 2x minus a 3, and then maybe times a -3x minus 5 to the second power, and then maybe a 5x plus 2 to the third power. All right, that's in factored form. If I multiply that all out, which I would not want to do, but if I multiplied this all out, I could write 2 of these, I could write 3 of these, I could do repeated distributive property, it would get a really, really long polynomial curve here. All right, now if I want to try to find the degree of a polynomial in factored form, I'm going to take each one of the exponents of the factors. All right, so this factor has an exponent of 3. This factor has an exponent of 2. This factor has an exponent of 1. You can't forget the imaginary ones. So my degree is whatever I get when I add all those up. So 1 plus 2 plus 3. Going to give me a 6. All right, and again, the reason we're asking you about degree right now is because later we're going to take a look at the graphs of these polynomial curves, and you're going to need to, one, find the leading term. You're going to need to be able to find the degree. That degree is going to tell you in behavior what the graph is looking at. Okay, all right, so you'll have a few questions over degree at the beginning of your homework. Okay, now let's take a look at, let's go ahead and do a subtraction of polynomials just for practice. Let's do a couple multiplication ones. All right, we'll keep them relatively small. Let's say we're taking a -2x squared minus 3x, and then we're going to subtract a 5x squared plus an 8x. Okay, so this would be subtracting polynomials. All right, more specifically, I'm subtracting 2 binomials. All right, now the deal here is, all right, on subtraction, you've got to realize that you are subtracting everything to the right. So there's a set of parentheses there. You've got to go through and change all the signs. You can think of it as there's a -1 right here, and I've got to distribute the -1. But basically, the signs change on this portion right here. So let's just write signs change. Okay, so you should then probably have another line down, -2x squared minus 3x. I'm going to drop the set of parentheses on that first one because I don't really need it at that point. I'm going to go through and change my signs here. Minus 5x squared minus 8x. Okay, drop those parentheses because I distributed that -1. All right, then you're going to go through, add your like terms. All right, that's going to give me negative 7x squared. So let me screw the math up here. Then I'm going to put my x terms together. And again, don't drop those negatives. There's the signs in front are going to give you the signs there, negative 11x. And it turned out to be the way I wrote it, turned out to be there in standard form. Okay, so adding, subtracting, we're good. Degree, we're good. Okay, I'm going to draw a little squiggly here because I want to switch to multiplication. All right, of course, you can use FOIL. All right, obviously, if I've got FOIL is going to be used what? Whenever you've got two binomials. So if I had an AX plus a B times a CX minus a D, all right, a binomial times a binomial, you can use FOIL. All right, you do not have to use FOIL. All right, you can just do what I call repeated distributive property. It's the exact same thing. But if you think of it in terms of the repeated distributive property, then it's going to apply when you are maybe, say, taking a binomial times a trinomial, or a trinomial times one that's got 4 terms in it. If you just keep repeating the distributive property over and over and over, you ultimately get FOIL. And it, like I said, it will help for anything other than 2 terms times 2 terms, okay? So let's demonstrate this. Every now and then I don't finish what I start. I had quotations around that. Let's fix that. Okay. All right. Let's do maybe say an x plus a 3. So a little binomial for my first polynomial. And then so this doesn't get too long. Let's go x squared minus 2x plus a 10. Okay. Obviously, FOIL would not work on this one, so I have to have another process. Repeated distributive property basically says I'm going to take this term, I'm going to take the terms in the first one, I'm going to multiply them by everything in the second one. So I'm going to color code this so it stands out. X times x squared. What do we do those exponents? Add them up, right? Multiplying like bases, we add the exponents, so we did that the other day. X to the third. Don't let me screw up. X times negative 2x would be a negative 2x squared. And then this x times the 10, distributing there, would give me a plus 10x. Like I said, please don't let me screw up. Okay, now I've distributed the first term inside that first polynomial. Now I'm going to take the second term and distribute it to each of the other terms. Okay, so you just kind of got to stay organized. 3 times the x squared is going to give me a plus 3x squared. 3 times that negative 2x, negative 6x. 3 times the 10 is going to do a 30. If you do this in a systematic ordered way, you should be able to go back and find where you dropped a negative, find where you multiplied something wrong. Okay, now I can add some like terms. Nothing matches my x to the third. Putting together my x squared terms, I just get a plus x squared. Putting the x terms together, I'm going to get a 4x. And then the plus 30 on the end. And the way I wrote that, it ended up being in standard form again. Okay, so we've done tons of this in Algebra 2, right? Like you did this over and over and over and over in Algebra 2. Okay. One that people miss a lot, let's do that. How about if I did something like, I don't know, say a 4x minus 8 and then quantity squared. Okay, now on this one, what I see a lot of, which is the wrong way to do it. Let's do it the wrong way over here. All right, I see a lot of people take this 4x and then square it, and they write down either 4x squared or they write down 16x squared. And then they square the second term, and they write down a minus in between, and they get an answer that looks like that. All right, that's the wrong way to do it. You cannot just square the first one and then just square the second one. All right, and that's just a common mistake of what people do. All right, so don't do that. All right, instead, this is my base, and it's being squared. So every time you see a binomial being squared, you need to take 4x minus 8, write it down a second time. All right, if it was to the third power, you would write it down 3 times. If it was to the fourth power, you would write it down 4 times. All right, and now hopefully you clearly see that you could use FOIL on this. You got a binomial times a binomial. You can either FOIL it or use repeated distributive property. All right, now I still am going to get, when I multiply those first terms, I do get a 16x squared. So that term is correct. All right, if I do outside terms, then I have a minus 32x. Here I'm going to have a minus 32x. And here I will get a positive, because negative 8 times negative 8 is a positive 64. And then add these two in the middle. So a 16x squared minus a 64x plus a 64. All right, did I multiply everything right? Are we good? Don't let me make a silly mistake. All right, but clearly you can see that squaring the first one, squaring the second one, and then just dropping that sign does not work. Okay? So just something to watch out. Now, like I said, if this was a third to the third power, you would write it down 3 times. Okay, so let's go ahead and do one. This to the third power, just so you can kind of see. If I had, like, let's keep the numbers small. 2x minus 1 to the third power. Okay, so I am going to write that down 3 times. So I'm going to write down 2x minus 1. I'm going to write down 2x minus 1. I'm going to write down 2x minus 1. All right, now you cannot do repeated distributive property as it sets now. You really need to pick, like, the first two. Pick these two, multiply those, and then just kind of keep this with it, and then do repeated distributive property. Okay, so going left to right, I've got a binomial times a binomial here, so if I wanted to, I could FOIL. Okay, so I could do a 4x squared minus 2x on the inside. Some of you are going to be able to add those in your head. Negative 1 times negative 1 is plus 1. Okay, now I've just multiplied those two. All right, and I'm going to go ahead and combine like terms here in a minute. But keep the set of parentheses around it because you just created a polynomial when you multiplied those. Bring this one down, 2x minus 1. I'm going to go ahead and add some like terms there. 4x squared minus 4x plus 1. Now, at this point, you've got to distribute. I generally distribute everything that's in my left polynomial to everything that's in my right. Different people I've seen do different things here, but that's kind of what I'm going to do here. You ought to be able to follow this, okay? I'm going to take the 4x squared and distribute it to 2 places. So 4x squared times 2x is going to give me an 8x to the third. Now I'm going to distribute it here. 4x squared times that negative 1 is a minus 4x squared. Now, there's some people will just keep writing horizontally, which there's nothing wrong with that. But if I do the middle term now and distribute it, what am I going to get? I'm going to get a minus 8x squared, right? It's going to match this term right here, right? So why don't I do minus 8x squared and put it underneath, because I know I'm going to have to add those. Anybody ever done it this way? All right, negative 4 times negative 1 gives me a positive 4x. Now I'm going to distribute the 1. 1 times 2x is going to give me a 2x, but instead of it keep stringing them out, why don't I put this underneath? Because I know I'm going to have to add some like terms. And then 1 times negative 1 is going to give me negative 1. All right, has everybody showed you that to kind of shorten it up a little bit? Okay. I mean, you don't have to do it that way. If you want to just string it all out on the line of your paper, you can. All right, but if you know you're going to have to add those like terms, go ahead and put them underneath each other. All right, then this is going to give me a what? This is going to give me an 8x to the third. Adding these two, I'm going to get a minus 12x squared. Adding these two, 4, 5, 6, I'm going to have a 6x, and then a minus 1. Everybody follow that? I mean, obviously, like a lot of people will just string it all out, but that kind of, it works. Shortens your work a little bit going across your paper. Okay. All right, so everybody good so far? Okay, now I'm going to put one on here that's going to be rather challenging. I'm going to let you try it on your own and see how far you get. I may give you one hint or suggestion after I write it down, and then we'll let you try it on your own. So let's go with 3x plus a 4y, quantity squared, minus 4x minus 5 times 3x plus 1. And I do want to talk about this before I let you try this and start it on your own. Okay, over here on the left, I've got a binomial squared. Not a big deal. I'm going to write that down twice. I'm going to FOIL it out. All right, now stop and think about what the rest of the problem says. This says minus everything to the right because this is multiplied together. Okay, so this all goes together kind of like one thing. So I am minusing everything to the right. If I subtract everything to the right, don't I have to go through and ultimately change the signs? Okay, I don't want to change the signs now because I haven't multiplied, but after I do the multiplication, I need to change the signs. So it might help you to put some square brackets around that just so that you remember after you have FOILed this out and you've got a polynomial in here, you won't forget to go through and distribute this, change the signs. All right, so I'm going to give you a few minutes to try that and see if you can get it right without messing up. Okay, did we get it? I'm going to say as long as several people match me, then hopefully I didn't miss it. Yes, Carly? This one? Yes, I'm not going to be real picky in the order in which those terms are down there. Okay, I'm going to be thrilled if we can get all the right terms. Okay. And technically, yes, you should have this many lines of work. Now, it may not necessarily match mine exactly. All right. You might have added those like terms when you went from here to here before you distributed the negative. I didn't. I distributed the negative, and then I added the like terms later. Some of you, when you FOILed this out, might have been able to add that in your head because you're getting pretty good at FOIL at this point, which I didn't. I showed the steps. All right. So even though your steps may not match identically, you should still have, on a problem like this, you should still have multiple lines of work down on your paper. Okay. This stuff, honestly, you did so much of it in Algebra 2, wasn't designed to be hard. All right. My guess is if you miss a question, it's going to be because you dropped a negative, because you multiplied wrong. Maybe these terms were written out and you wrote them so sloppy you couldn't find all the matching terms or whatever. It's going to be a silly mistake like that. It's not going to be a concept mistake because you didn't know how to do it at this point.